Graph below show the battery level of the smartphone. It had an initial level of 20%, increasing to 60% in half an hour while connected to the power supply. Farhan then removed the smartphone from the power supply to watch a 20-minute long video clip before connecting the smartphone to the power supply again.
A. Find the battery level of the smartphone when Farhan was exactly halfway through the video clip. B. Find the rate of increase in the battery level of the smartphone when it was connected to the power supply again.
Here are the solutions as follows. A. From the graph, the battery level was 50%. This is shown from the shortest line in the graph, which is slanted southeast. It starts from the time which is 30 minutes to 50 minutes, as the video's duration is 20 minutes long. While from the battery percentage, it decreases from 60% to 40%. From this, we can conclude that the shortest line is equal to 100% of the line. The question is asking about the percentage of the battery used after the video has reached halfway. Halfway of the video is equals to half of the line, which is also equals to 50%. B. To find the rate of increase in the battery level, we need to calculate the gradient of the line from the 50th minute to the 90th minute. This can be shown in an equation. Gradient is equals to 100 minus 40 over 90 minus 50, which is equals to 1.5% per minute. This is because in the graph, there are two increase for the battery level, and we need to find the average rate increase of the battery level. So the rate of increase in the battery level is 1.5% per minute.
The graph below shows the heart rate in beats per minute of an adult who is at the park. He ran at the bed for the first 10 minutes, after which he began to breathe for 10 minutes. He then slowed down for 5 minutes before brisk walking again for a further 5 minutes. He then jogged at a constant speed for 10 minutes before gradually slowing down.
A. Write down his resting heart rate. B. Find the rate of increase in his heart rate as he brisk walks for the first time. C. Find the rate of decrease in his heart rate as he slows down in the last 20 minutes.
Here are the solutions. A. In a problem, it is stated that the dog rests at the bench for the first 10 minutes. In the first 10 minutes, it is shown clearly from the graph that his heart rate is 60 beats per minute. So, his resting heart rate is 60 beats per minute. B. During his first brisk walk period, there is a 2 heart rate shown in the graph. The initial heartbeat, 60 beats per minute, and the final heartbeat, which is 120 beats per minute. Acceleration or rate of increase in heart rate is equal to final heart rate minus initial heart rate over that period of time. In the graph, the time is about 10 minutes, so the increase in heart rate or acceleration is 120 beats per minute minus 60 beats per minute divided by 10 minutes, which is equals to 6 beats per minute squared. C. In the last 30 minutes, there are again two heart rates. These are 140 beats per minute and 120 beats per minute. Rate of decrease is deceleration. To find deceleration, we need the final heart rate, initial heart rate, and the time. Using the formula, rate of deceleration is equal to final heart rate minus initial heart rate over time. We should get 140 beats per minute minus 120 beats per minute over 20 minutes. It is equal to 1 beat per minute squared.